Okay, in this question, what you have to do is, first of all, draw a diagram showing all the outer electrons to represent a molecule of oxygen, O2. Okay, O2 is covalently bonded, means they share their valence electrons with each other. You'll have 2 valence electrons shared from each atom, because oxygen has a valency of 2. If you've learned about unshared pairs, you can remember that the unshared pairs are not used in bonding. So anyway, you might not have learned that because that's not part of your National 5 learning. So if we draw the petal diagram, you don't have to draw the inner shell with 2 electrons, but if you do, they must be correct and there must be 2 electrons in it. You must show all the outer electrons, so each atom must have 6 electrons in its outer shell. And each atom has 6 electrons. You must show these, and these 4 cannot be in this zone here in this diagram. There must be 4 electrons in here and 4 electrons around here, and I don't think you need to pair them up. They can be distributed any way you like, right? Or you can use the Lewis dot diagram method, which is also acceptable. All the dots can be the same, or you can have dots and crosses in various different ways. There's no particularly correct way to do this because technically the electrons are all identical, so using a different symbol to represent an electron is kind of not correct anyway. Anyway, one of those things will work for you, and that's all you had to do. Name an element that has similar chemical properties to oxygen. Well, all you have to do is pick one of the elements in the same group as oxygen. If we go to our data book, oxygen, sulfur, selenium, tellurium, polonium. Okay, and they even allowed you livermorium, but I wouldn't worry about those. Basically choose sulfur. Choose the next one down in the group. That'll keep you safe. But any of those group 6 elements would be fine. The graph shows the solubility of a compound containing oxygen at different temperatures, right? Again, whether it's oxygen or not is irrelevant because they don't tell you it doesn't really matter about the compound. Here's the compound, here's the temperature, right? This is your independent variable, this is your dependent variable, right? And the way to answer these relationship questions is as the independent variable increases or decreases, the dependent variable increases or decreases. You need to burn that little phrase into your mind for chemistry and biology and for physics. So as the independent variable increases or decreases, the dependent variable increases or decreases. So what you do is you substitute in here the name of the independent variable, which is temperature. You substitute in here the name of the dependent variable, which is solubility of compound. And you might even just get away with solubility. In fact, you do get away with solubility. And then you have to decide here, increases, decreases, or stays the same, increases, decreases, or stays the same, right? So here's the sentence in the end when we get it all down, is as the temperature increases, the solubility decreases. You get the marks, only 1 mark, right? Here's part D. Oxygen can react with fluorine to form oxygen fluoride molecules containing covalent bonds. Molecule of oxygen fluoride is shown. Here we go. Oxygen and 2 fluorides. Basically looks like water, right, with fluorine instead of hydrogen. State the name used to describe the shape of an oxygen fluoride molecule. Right? Well, the answer given in the marking instructions is angular. And that's the approved name for that shape in National 5 chemistry. But it's also acceptable to write bent as far as I'm concerned. Now, doesn't appear in the marking instructions, but if you wrote bent, I'm not sure if you get the answer, the mark or not. But bent is a perfectly acceptable term for this structure. And it may be that they don't allow that. So you're better off sticking to what you've been taught, which is angular. But if you wrote bent, you'd be very unlucky not to get the mark, but they don't say they're giving it to you. So there you go. Circle the correct words to complete the sentence. A covalent bond forms when 2 nuclei. All right, well, nuclei have to be positive because there's only protons in there and no electrons. So positive nuclei held together by their common attraction for a shared pair of electrons. And this is basically a definition of covalent bonding. If you want to learn that as your definition of covalent bonding, you'll not go too far wrong with that definition if you're asked to produce it. There you go. I don't think there's anything. I mean, you're not going to write, this is nuclei, right? So you've got to write positive. Nuclei are always positive. The only sticking point here is going to be their common attraction for a shared pair of, and only electrons do bonding. So you should be able to eliminate those two. That should be a relatively straightforward question. Okay, good.